All right, everyone. We will get started here in a moment. Just letting everybody kind of trickle in from the waiting room. But really excited to be with you here tonight. Thanks for joining. All right. Looks like the bulk that was in the waiting room has made it in. So we can get started here. Um, Hey everybody, welcome. We're really excited to be with you tonight. My name, for those of you that don't know me, is Chad Kleinert. I'm the product manager here at Ossio. Um, and we're excited to kick off this first ever FIBERchat in our new webinar series. This evening's focus is on hand and wrist surgery. And our goal with all these Fiber Chat series is to kind of create an informal atmosphere, bring together innovative surgeons, meaningful case discussions, to really advance the way that we think about OsseoFiber, and talk about clinical practice using biointegrative technology. So throughout tonight's presentation, there is a Q&A button that you'll see at the bottom of your sidebar for Zoom. Feel free to send questions in using that button. I'll monitor that throughout the presentation, and we will periodically take time, definitely at the end of the talk, to respond to those questions. So tonight's session, it promises to be a great one. We're joined by a surgeon who's been at the forefront of upper extremity fixation and one of the earliest adopters of OsseoFiber. It's my pleasure to introduce our speaker, Dr. Bruce Monaghan. He's a true pioneer in biointegrative fixation, with a special focus on hand, wrist, and elbow. Dr. Monaghan's been at the forefront of innovation in this space and is among the earliest adopters of OsseoFiber, with nearly 100 cases using biointegrative implants. His experience and insights have helped shape the evolving landscape of biointegrative fixation and orthopedic care. In addition to his clinical expertise, Dr. Monahan is an influential leader in the field. He currently serves as the president of the New Jersey Orthopedic Society and sits on the board of directors for the Eastern Orthopedic Association. We're honored to have him here tonight to share his perspective on advanced fixation techniques, the future of biointegrative solutions, and talk a little bit about OsseoFiber as well. So please join me in welcoming Dr. Bruce Monaghan.
Thank you, Chad.
Yeah.
Just one correction. I was president of the New Jersey Ortho Society. That was a long time ago. Almost when I had hair, but I do. I still like to get involved in seeing what the evolving field of orthopedics is, and Eastern Orthopedics has been a great society to be a member of that has been helping me keep topical. And I'm very excited to talk about this material. Um, it has really become an implant material that I strongly believe in, and I'm excited to see it evolve and come into the hand surgery space in a meaningful way. So I thought I'd start the talk by talking about biocompatibility. It's something that profoundly impacts what we do in orthopedics in general, but we might not think about it often. And the traditional definition of biocompatibility was an ability of a material to exist in contact with the human body without being harmful or toxic. Essentially, you know, coexist but not interact. It was sort of a founding principle, but in spite of that, that was something that guided the use of orthopedic implants for the last 150 years, be that stainless steel rods, screws, and plates that we traditionally used when I was a resident a long time ago, whether it's evolved into PEEK sutures, which is a biocompatible material that, once again, doesn't integrate. Um, and basically, the traditional definition was to coexist and primarily do no harm, but function with a role, mostly a biomechanical role, while the biology of healing moved forward. Um, but, as we went to understand the fact that even from a non-biological or a mechanical standpoint, that stainless steel had a modulus of elasticity that was so much greater than bone that we were going to be having to deal with stress shielding, we evolved and started to use titanium implants where the modulus of elasticity was more in line with bone, so that stress shielding, which was an untoward effect of that implant, not a biologic effect, but a mechanical effect with a biological consequence of stress shielding, was happening. And so, in addition, cellular responses to material have been studies for decades, and it really speaks to defining a new definition of biocompatibility, and that is the ability of a material to perform with a appropriate host response, but also the material must perform a specific application. And I think that in that context, a lot of people have investigated implants that might be biodegradable, meaning they are not supposed to be there forever. And a lot of that initial study decades ago was in suture materials, polylactic acids, polydiaxones, or PDS type sutures, where you have strength. It allows a suture line to heal, but eventually the material no longer exists there. And some of this material, like the polylactic acids, was where the initial foray into orthopedic biodegradable implants first came out in the late 90s. And they seem to have some success, but some unpredictability. And the PLLA material was built, and structure and stability that the material you wanted the material to have as an orthopedic implant was conveyed by crystallinity, a large molecular weight, uh, 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 implants, and that led to an untoward consequence where the the biodegradation of this material was not in any way predictable. Sometimes it would, in certain structures, it would degrade in a uniform fashion, and then all of a sudden there'd be bulk degradation, or when it released lactic acid, it would drop the pH and create an intense inflammatory and or foreign body reaction. So, you know, the predictability of PLLA led to, you know, it wasn't rapidly or uniformly adopted when it came into play. And so, when we start to think about the biologic environment and defining an ideal bone implant with the new definition of biocompatibility, you wanted a material that's there when you need it to, and not there when you don't. So you needed a, a material that will have a controlled degradation. You need a material that has the strength you need it to perform, and maintenance of that strength during the healing process until the healed bone can take over the duties that it should perform. As this product degrades or integrates, you do not want an inflammatory response that will tip the balance of the biomechanical stability out of favor. And then when the material is gone, you want normal bone. And as I said, you need a material that will perform the test. Do you want a suture implant to hold suture in place? Do you want a compressive screw? Do you want a plate and screws? So you have to be able to machine this material to serve a function. So this technology platform is very, very interesting in that it is machined in such a way. It's a composite implant that gives strong time zero fixation strength. It gradually is integrated with normal bone. And then once fully integrated, there's only normal bone. And the way it combines it is it's a composite of PLDLA. So the polylactic acid, both the L and D enantiomer, is placed in an amorphous structure to be the biodegradable implant. The strength of the implant isn't due to the crystallinity of the PLLA, but it's due to the uh, woven textured material of many materials that we understand to be osteoconductive bone graft substitutes, the silicon dioxide, the calcium oxide, the magnesium oxide. And it's built in such a way where when the PLLA starts to dissolve and creates an inflow for fluid to come in and start resorbing and degrading the osteoconductive material, no longer is the PLLA going to be acidic because most of the osteoconductive material is basic. So it's going to be a pH matched and fortunately predictable process of degradation. And because it's a predictable process of degradation, there's a predictable process of strength degradation of the implant you put in such a way where you can um, you can have predictable strength until intrinsic healing has occurred. And then the material, the fibro architecture of the osteoconductive material can be built to be a plate, be a compression screw, be a interfrag screw, or be a mesh, or be a suture anchor. So what's the data? Um, well, time zero data, osteofiber can be constructed to be 1.5 times as strong as bone, which is within line of what titanium was versus the modulus of elasticity. It's much stronger than peak and much stronger than the conventional bioresorbables. This is the most important part where as the bone heals to get normal cortical strength over 12 months, the osteofiber is degrading in a very predictable fashion. There's no bulk hydrolysis. There's no intense uh, foreign body reaction that will rapidly degrade the implant that you have. So as the bone integrates to replace the strength, it is matched by the degradation of the osteofiber implant. So it's really a very ingenious in the way it was designed as this composite of two materials. And in an osteotomy model in sheep, you could see that when you put the screws in to fix an osteotomy, there's stable fixation at 2 weeks. Reduction is being maintained and fusion occurs in 3 months. This is, I believe, in a sheep model with 100% bony bridging. And even at 6 months, the implant is still present, still maintaining structural integrity and integrating, but there's no adverse biologic response. And then this is a standard suture anchor on the left where you see peak, and you know that peak will always coexist with the bone, but it will never integrate. Well, here you see the osteofiber suture anchor on the right, and you actually see vascular invasion and bony ingrowth such that in at some point in the future, there will no longer be an osteofiber suture anchor. There will only be bone. And this was another osteotomy model early on in sheep where they hadn't yet developed the osteofiber screws. So these metal screws and then and a plate, and you can see the arrow pointing to the plate in between the screws. And then the next picture shows histologically what happened at 13, 26, 52 weeks, 78 weeks, and 104 weeks, which is 2 years post-op. And basically you see the initial stability of the implant integrity is maintained. At about 52 weeks, you start to see the implant integrity is being changed, but the bony growth has more than made up for it. And then by 104 weeks after implantation, you don't see the original implant. You don't see a reaction. You just see normal bone. So this is sort of an interesting new material that will meet the needs of biocompatibility as it's been defined in 2025. The product offerings for hand that I've been using have been initially developed. The two ones that I initially used were developed in the foot and ankle space, but were easily integrated into hand use. And they are the 3.0 and 4.0 cannulated trimmable nail. That affords good intramedullary strength, and I've used them extensively for intramedullary fixation of metacarpals and selective proximal phalanges. They are material that you don't have to have a large stockpile of different sizes because you cut the implant to the size you need. The rather fixations rather than a screw are conveyed by barbs that are quite strong, and the hexagonal cross-sectional area is quite strong to resist bending and rotation. But as opposed to the 4-5 screw, which is the next thing I'll talk about, this implant is inserted over a K-wire for an intermediary for the right configuration metacarpal fracture, and then compression or distraction, to get it out the length, is conveyed externally, and the barbs hold it into the position you want. Whereas opposed to the 4-5 screw, where compression is conveyed by the screw. It comes in a sterile kit, and it's disposable, so you don't need a lot of inventory and a surgical center, and can be brought in rapidly. This is the fixation nail that came out about a year and a half ago, and it's slightly larger, so it may have less opportunity for fixation of ring finger metacarpals with a diminutive medullary canal, but nonetheless, it's 4-5, and it's a gradual tapered nail, and the taper is structured so that most metacarpal, even though most of the intramedullary screws that we started to use weren't designed for metacarpal fixation, they were designed for compression. Most metacarpal fracture configurations, you don't want a large degree of compression. And this nail is built to give you some degree of compression, but not a large degree. And the ingenious uh, person who figured out how to shorten this, essentially, this is um, a an old school sterile medical pencil sharpener. So you are tapering the leading edge in a controlled fashion so that you can fix it, and you restore the compression by cutting off the leading edge. Whereas the medullary canal fixation that you do with the 3 and 4.0, you cut off the lagging edge to get your length. Here you cut off the leading edge and taper it and restore the compression. It really does have unmatched torque comparison to several metal screws. And most importantly, it's sufficient for these fractures to heal. It's stable for early fixation and early motion. And as you'll see in the reason I started to use this, it's gone when you don't need it. They also have developed an Osseo cannulated compression screw, much as most the old traditional Herbert Whipple screw, where you can get compression. And I found this very useful for scaphoid fractures, for some periarticular fractures, radial styloid fractures, and have been very useful. The other interesting thing for many of us who you know, only had hair in the early Bush administrations. Um, these screws do not they're not self-tapping, so these screws have to be tapped, which is not something most orthopedic fixation may be absent. Pedicle screws are self-drilling, self-tapping, but the way that this material is machined, you can't have that. But it's just an added step, and nothing that really is any much of an impediment. It's just something to know that it's a slightly different process than most of the screws we use. So I'd like to thank you on your attention for the sort of the biologic platform for the OsseoFiber. And if there's any questions that um, I can answer, or Chad, being the product manager, can answer, we on the OsseoFiber, we'd be happy to it now, or we can hold our questions till later.
Yeah, we have a couple come in. I'll touch one. This one in about the threaded nail regarding the threaded trimmable fixation nail. When thread pitch is cut, is a compression considered compromised? So the compression actually for that product is not compromised, um, un because you're trimming the leading edge. So the variable pitch occurs at the most proximal 20 millimeters of that implant. Um, I think for now, that's what we have.
Okay,
As you all have questions come to mind, feel free to put them in the chat and we will make sure that those get addressed.
perfect. So I just wanted to sort of share um, why I started to use it, and why I continue to use it. And then someone put this nice title in, My Journey into Biointegrative Fixation. But, so yeah, I have a ghostwriter. But no, so I just wanted to show you my first case. This was, and it's sort of interesting. I think a lot of my personal adopting of intramedullary fixation for metacarpals and some proximal phalanxes occurred with COVID, and COVID continued to age a new generation of teens that were even angrier and would punch walls more frequently. And we didn't have a lot of elective cases. So these were the cases that we were had the opportunity to do from like early 2020 to 22. Um, and so I did a lot of intramedullary fixation of metacarpals. And this gentleman was emblematic of some of the psychosocial challenges we have. This is a 25-year-old that decided to punch a wall and had two metacarpal fractures. You can see I didn't use a specific, I did not use a specific uh, metacarpal nail. I just used a cannulated compression nail. I was very happy with the result. Um, the, as is often the case with these individuals, he left me early, about 2, 3 months later, being asymptomatic and having full mobility, but not having the emotional maturity, not that I should judge either, but not having the emotional maturity not to punch something else later. So he comes in 2 years later, and this is what I am left with. Refracture. It might. One might argue, were these non-unions? I'm not sure, but refractured and bent metal screws, and I really don't really. I was where I was, but I don't ever want to be here again, if at all possible, because this became a difficult challenge to both achieve repeat fixation and to remove the implant, which now was fixed in a flex position. So I had to do a wide open. I did a dorsal osteotomy. Um, I had to do an arthrotomy to get the distal fragment out. So essentially, I went in, I did a dorsal corticotomy, osteotomy at the apex of each bent screw. I tried to cut the screw, and then I brought them out in antegrade fashion from the proximal end, and retrograde fashion, if I could, from the distal end. But I had to go retrograde through an arthrotomy in one of them. And so now that I got it out, how was I going to fix it? Intramedullary fixation, plate and screws, um, and this gentleman was still going to be this gentleman, and I still he could have, you know, if this was indeed a non-union, is there a risk of a further non-union and fracture fixation failure again, and how to integrate it? So what I ended up using was the Osseo nails, thanks to one of my distributors who saw this product and thought this might be great for this case. And it actually really did the trick, because you can see on these x-rays, you can see the osteotomy that had to be done to get at each fracture. There was a little bit of metal debris to get it out on the fifth metacarpal, but I was able to achieve um, very good alignment and stable fixation. And it sort of sold me on the concept of I definitely don't want it to be there all the time. I wanted to be gone when the job is done. And this has been actually 4 years since I did this revision case, and he has stayed away from me. Maybe someone else in New Jersey has acquired him in a deal at the trade deadline, but I have not seen him back with a repeat fracture. So I was very excited with this, and I started using these for in place of the metal screws. So a displaced fifth metacarpal neck fracture with 90 degrees, and how much angulation is too much. It's always a matter of debate. That's sort of not the focus of my talk, but in my personal opinion, if there's so much of a bend that there's a pseudo extensor lag at the PIP joint, those are the fractures that I will fix. And you can see that I was able to achieve good alignment. Um, in the middle, you can actually you can start to see a shadow of an implant. And then this is a later X-ray where it starts to show healing. This was a short oblique fifth metacarpal neck fracture that was rotationally unstable. Intramedullary fixation isn't great for long obliques, but if you can achieve a stable union and put the screw in stable fixation, I think you maintain the rotational alignment that you've achieved by open reduction. This was a 19-year-old EMT, wanted to get back to work quickly. So in her case, I decided, and I think it was a work-related injury. So in her case, we decided to go with the implant. As you can see, I used a reduction clamp to correct rotation. I percutaneously placed the K wire, and then I lengthened the incision. I don't always do a formal 1 centimeter incision to repair the extensor tendon, but I do it sort of percutaneously. And she achieved very good alignment with correction of the rotational malalignment. And then what I tend to do is I put an ulnar gutter base on so that it's all focused about rapidly achieving motion. So even after they leave the OR, before they see me in a week, I encourage them to move the MPs and PIP joints completely, and that obviates the need for therapy in some, but not many. But typically, um, as opposed to 4 weeks, 3 to 4 weeks, where this fracture is healed and we're starting motion, they are typically have full motion at the 4 week follow up. This is a comminuted diaphyseal fracture, which was displaced and obviously unstable. And I was able to achieve adequate alignment, not perfect, but adequate alignment and length. And you can see the implant over the area. And most importantly, in this case, the amount of comminution um, allow it, requires that some stable fixation of the barbs is achieved, and it really did maintain length while it heals. I've done sort of in the cadaver labs. I've taken intercalary segments of the diaphysis out with both the barbed nails and the tapered trimmable compression nail, and you can have a defect of several centimeters, and the fixation that you achieve in the proximal and distal is sufficient to hold it out the length. Um, and I've been very happy with it. And it's going on to external healing. And, when we do stable compressive fixation, internal healing doesn't leave a lot of extra callus, but much like intramedullary fixation for the femurs and tibia, extra osseous callus is sort of par for the course, and that intercalary fragment is healed in quite well with good alignment. Here was a prison guard who fought the wall in the wall one. He had comminuted proximal diaphyseal fracture in the middle, midshaft, the ring, and an intra-articular fifth metacarpal base fracture. So obviously, the fifth metacarpal base fracture is not amenable to this fixation. But I think if you get stable fixation and can start some motion of the middle and ring finger, and then I think with the percutaneous fixation of a fifth CMC base fracture, I typically start MP range of motion of the fifth as well. But to combine three-digit injury, to me, dictates that you have to do something that you have a stable enough fixation for early range of motion to idealize outcome. And so what I did here is in that ring finger metacarpal fracture, I bend it at the fracture site. I put the K wire in antegrade at the active fracture site. I bend the MP joint. I pass it out through the skin, and I think that gives me the best intramedullary alignment in the distal fragment. Once I do that, I back it out until it's at the fracture site. I do a reduction, and then I pass it across the proximal fragment. And then you can see this K wire that has been done in that fashion is that's the reaming or drilling to fit the right implant, and then you can see the percutaneous pins as well. The short oblique metacarpal fracture in the middle was also fixed with an intramedullary fixation, which once again it's a little close to what I'm comfortable with, but it ended up healing quite well. This is an isolated index metacarpal fracture, short oblique to transverse. These are ideal for fixation with compression, and this gentleman healed quite well. This is one that was a proximal phalanx fracture that was rotationally off, and I started retrograde fixation after a reduction. What you can see, and this is the drill for the 3.0 and 4.0, and the medullary canal in the proximal phalanx is going to be a little smaller. So 4.5 probably would not be amenable to this. I've pushed it recently on a very fragmented fracture, and I was able to get reduction, but I couldn't really feel comfortable drilling in that subcapital neck area where the canal was very narrow. So I ended up having to put the nail antegrade past the fracture, but not into the head like I typically do. In this case, we're doing it retrograde. And what you can see with this drill guide is this, when you're measuring, this will allow you a measurement that will incorporate some countersinking. So this is the fracture, and this is the healed fracture. They're quite happy, and um, early motion could be achieved as opposed to antegrade percutaneous pinning that has to be held for 3 weeks. This is one that you might not like the looks of the result, but this is a laborer who uh, decided he was working up in Long Island on assignment. He was in a hotel. He went to the gym and he slammed like a 45-pound stainless steel plate from the weight room on his hand. He had a combined proximal phalanx fracture, which was comminuted, albeit non-displaced in the middle finger, and comminuted in the index finger with displacement, and a metacarpal head fracture. So I felt this would be a good one for fixation because when I've had to fix shaft proximal phalanx fractures with plates, it is a big endeavor. It is a significant operative approach to that. And I've often found regaining motion is a very slow process with a lot of intensive therapy. So I knew when this sort of combined, multiple fracture, like an open like a floating metacarpal, floating MP joint, essentially at the middle finger. I wanted something with stable fixation that allowed me early motion, but not a lot of soft tissue uh, injury. So I was able to put an intramedullary nail that I put in retrograde fashion in the proximal phalanx and the index finger. I did an arthrotomy at the middle finger MP joint and did some oblique screws, and this was incredibly surprisingly comminuted. This was probably the most challenging of all the fractures. And then while I was there, I flexed it. I translated the base of the proximal phalanx dorsally, and I put an antegrade rod through the middle finger proximal phalanx, and this gave me very stable fixation, and I could start early motion. And yes, because of the crush injury, it was a prolonged recovery. But in my opinion, versus having to plate these, I think he returned to work in like 6 or 7 weeks versus people that could take 3 or 4 months to get the motion back with this injury. Yeah, he didn't get full motion. He probably lacked about 10 or 15 degrees at the PIP joint, but given the injury, I was happy with the result. This is an arthrodesis that I performed at the IP joint of the thumb with a cannulated compression screw. Once again, immediate stability. Very happy with the result. And um, in the other thing, when you're looking for fusion and healing um, around a screw, sometimes, particularly with scaphoids, you can't see because the implant is sort of obscuring the picture. You have a better sense of how much crossing bone union is occurring when the implant is, dissolving, mostly radiolucent, and at 2 years isn't there. Still, in fractures like the scaphoid, I still will require CAT scan to confirm healing because the stakes are so high, but it's a nice added feature of this implant. And now this is another hybrid that I use. This is an articular shear fracture, not a lot of territory for a plate fixation given the volar the length of the volar fragment to the articular surface right here. So what I did was I reduced it. I used sort of a hook plate, sort of like the Orbe plate for the teardrop fracture. This happened to be um, a fibular hook plate that I just bend, and this is sort of my go-to plate for these periarticular fractures. But then I put an orthogonal radial styloid. In this case, it was a trimmable nail in, so that I was able to achieve uh, perpendicular two-plane fixation. And I've done this for a few of these high-energy articular shear fractures. This is a bit, so a denizen of business who needs a new hobby because hockey is too violent. He slammed into the wall and had a fracture that is relatively benign here, but he had something suspicious for a scaphoid fracture, which was confirmed. This is the articular fracture of the radial styloid and a fracture line across the proximal pole of the scaphoid, some reactive fluid in there. So I felt that fixing both of these at once would allow him some early motion. Proximal pole scaphoid fractures, I like to be more aggressive at fixing so that AVN and prolonged union is minimized by the compression that you achieve from the fracture site. Um, and this is a case where it's really hard to see the implant, but you can start to see the healing across the radial styloid and the healing across the scaphoid without sclerosis or AVN of the proximal pole. And then here's another example where you can actually see the implant right down the axis of the scaphoid, and you can see a little bit of the implant in there. So I'd like to thank you for your attention. I'm more than open to questions if anybody has any. I'm very happy to share this product. I'm very excited that the direction the company keeps um, pursuing new products. I know that I've had a handful of opportunities to use some of their suture anchors in the elbow and scapholunate ligament area. I think some of them, there's a challenge. The implants right now need to be machined, and there's some limitations. So at least the smaller implants length preclude me from a lot of finger fixation. But I think in time that will come in and that will change. And more importantly, they're always open to listen to ideas from people that are innovative thinkers in presenting the challenges that we continue to meet in some of these complex hand and wrist problems.
Thank you, Dr. Monahan. That was awesome. We have had several questions continue to trickle in. So maybe we could touch on a couple of these.
Sure.
And feel free to continue to send some in. Um, we talked a little bit, so there's several about scaphoid. We talked a little bit about your scaphoid experience. Do you think the osteofiber material will reduce the risk of a non-union for scaphoid in particular?
Um, I think I'm not sure. I think it has very good, strong time zero compression. The the question in skateboard that hasn't been answered is how strong does it need to be? I think it's as strong and it's sufficiently strong as the metal implant. It's not going to be as strong as some metal implants for bending, but I I think it's benefit. I think it's equivalent to screws at time zero fixation. I think the added benefit is and I think how many scaphoids are you still struggling with at 2 years? You're not many. And I don't think if you're struggling with them between a year and 2 years, because you have a metal screw that's still strong in there, is going to help you. At 1 to 2 years, if it's not healing, the fixation has been lost by windshield Liebberg. So I don't think that the implant is much different than the metal implant for what we need it to accomplish. I like the fact that I can look and actually see the trabecular bone, the crossing bone, and that it's not obscured by by the metal implant, and that each time I have a question is, have I achieved sufficient healing, rather than needing to, these scaphoids are all young teens, rather than needing to do another high radiation CAT scan. I can get sufficient info and get one CAT scan to sufficiently confirm complete healing. I hope that answers your question.
I think it did. No, we do have a lot of interest in scaphoid here, so that's good. No,
Yeah.
actually, another question on scaphoid. How for scaphoid fractures in particular, how do you confirm the implant is across the fracture site?
So the um, K wire and then the screwdrivers at the lagging site. So you know how far you've sunk it, you know your length, and the K wire length. You sort of match the length of your K wire to the implant. Now, those 3.0 and 4.0 implants are individual by 1 or 2 millimeters. So yeah, that's not a trimmable thing.
Right.
I have um, I have used this in some perilunates, and if it's comminuted, I will put an additional K wire anti-rotation and for additional fixation that I know I have to take out.
And I'll just comment anecdotally there that I have heard some surgeons take a look at adjusting the KVP of imaging because you can see a slight silhouette of the implant at times.
Yeah, I just like you most certainly can, but I do like most of these kits allow, yeah, they're slightly different ways, but you say, okay, a 4.0 kit, how do I judge length with the, and then you basically judge length with one method. With the 4.5 screw, the inserter shows you in a different way, but it shows you where you're going. I've
Right.
always done percutaneous implants if I can for scaphoids because I do think less disruption of soft tissue if you can achieve adequate alignment before you're putting the K wire in. That's that's better. I also maybe it's just marketing, but like when you after you tap the screw and you're placing the screw in, it squeaks and it really does. It gives me the same feel of compression and I really get a good bite as that lagging end of the screw is being buried, and it feels equivalent to a metal screw to me in those last few turns.
Absolutely. We had a question come in. You typically use 3.5 or 4.0 compression screw for scaphoids.
I tend to use the 4.0. Just if I need something in addition with the K wire, and then I can downsize it.
Gotcha.
But I tend to use the 4.0.
And then what about any experience with the compression staples from Osseo?
I've used them, not a lot. I haven't, I just in my practice recently, I just haven't done a lot of intercarpal fusions where I think it would be useful. I think that I can see that they're very strong, though. At the, I did a talk about 6 or 8 weeks ago, um, which was the first one I did for Osseo, and someone came up to me and said, in some of these isolated forearm fractures that are very comminuted, it's sort of hard to get fixation while you're putting the plate on. So he's been using a metal staple. He holds it, he puts the staple on, it gives you some provisional fixation. He plates over it. I'm like, well, that would be an interesting thing to use for proximal ulnar fracture. So I actually used the osseo implant on that, and I was very happy with it, and it definitely it was easy to put in, and most of my staples were the temperature staples that would compress with temperature, but the way that this was loaded, you could see that there was adequate compression. So my N of two, I was very happy.
Um, let's see. Have you had any secondary surgeries on any of these implants? And what did that look like if so?
Have I had any secondary surgeries in these implants? I have not. Now, like the perilunate when I put a K wire in, and I took the K wire out, but I wasn't isolated. It wasn't because there was fracture fixation failure that was going in. Uh, the gentleman that got me to osseo hasn't come back to refracture. So no, I haven't directly had to go back in and replace this, but I do, I've futzed with it in lab, and it's even at time zero, it's something you can drill over if you need
Yeah, it
to
sounds like we don't know
reduce infection.
where that patient is.
I try to send them to North Jersey because I live in South Jersey, but we'll see.
Let's see. So for you touched a little bit on the 4-5 threaded nail being a good fit for certain anatomies. Maybe a little bit too big for the ring finger. Do you have difficulty mounting in or tamping in the 3-0, 4-0 nails for an application like that versus
No,
screwing in the 4-5?
I've been happy with, but it is, I mean, that's why the screw just seems to be a little bit more, you know, amenable to the natural elegance of the hand surgeon. But, since I'm from Philadelphia, I don't have that natural elegance, so I don't mind tamping something in. Um, but I just like, I think you need to, I like you're sort of reducing a metacarpal, you're holding it where you need it, and then you're impacting it into the right place. And so, provided you've drilled it appropriately, I have not had difficulty. If you're in your first couple of cases and you want to make a larger incision so that you know that you're not being negatively impacted by uh, neighboring soft tissue because it's a limited percutaneous approach, that's fine. The key is, you want to do little details, like you want to make sure that you're measuring to the tip of the K wire if that's where you're going, or if you feel you're going to stop short. You don't want to have to, because if you that and that's the other thing. If you're doing a fifth metacarpal neck fracture and the K wire is down there and you measure off it, and then you are going to drill it so that before you put the implant in, well, once you've achieved the measurement you want, send that K wire across the fifth CMC joint so it doesn't dislodge and you lose your reduction. But I think it's all about making sure that you drill for the length of the implant you're going to put in, and that you're not going to lose your fixation because the K wire comes out.
Got you. Let's see. We might be what it looks like this might be our final question unless any come in, but what would you recommend for DIP fusions with Osseo right now?
So I think it's sort of hard. As you can see, the IP fusion that I did was the thumb, so the medullary canal is a lot more capacious than the distal phalanges, the medial four digits. So there is um, a 2-4 non-cannulated nail that is has a lot of podiatric use, but the challenge is after you drill it, you don't have a K wire to advance it over. So if you're going to put a parallel wire or something in, or an oblique wire just to hold the position while you're putting the implant in, but it's a strong implant. I just think it's a little bit more challenging to place for the DIP joints. But I keep talking to Chad and he keeps taking my calls. So someday he'll call back and say he has a cannulated 2-4, which will solve this. So
You're right. All right. I don't think any other questions are coming in. I just wanted to say thank you so much, Dr. Monahan. That was an absolute pleasure to listen to. Excellent crash course
thank you.
on all things osteofiber and hand wrist. Um, so we're just so happy to partner and collaborate with you on things like this. So thanks for your time. Um,
Same. It's been a pleasure.
And I want to say thank you, everybody, for taking the time out of your busy schedules to jump on with us this evening. We have been recording this session, so we can distribute it if people missed it. I also just wanted to quickly mention that we have some really cool, exciting events coming up for osteo and hand wrist, particularly around the ASH Society meeting event in October. Um, for anybody interested in getting your hands on with some experience in a large lab setting, we'll be hosting a surgical suite event at ASH on October the 8th. And we'll follow up with communication um, on that event and other things to come at Osseo and Hand and Wrist uh, following this webinar. But with that, I'd like to say thank you again. Really appreciate your time and attention this evening, and hope you have a great rest of your week.